Right, we're finding normal percentiles. So this is some stats. They've given us a little bit of information. We're going to read. It says the average humerus bone length of a sparrow is 18.5 millimeters, and the standard deviation is 0.5 millimeters. The question they've given us is what portion of sparrows have a bone length that is 1 standard deviation or more, that's important, from the average. Okay, so they've written it kind of like what we have there. Proportion bracket 1x minus 18.5 greater than 0.5. Now, first of all, with the new stuff you're doing, I believe they put mu, right, as your average. So mu being essentially our mean, and sigma being our standard deviation. So this is how they're representing them. Now, what this is saying here, what this is trying to say, is you need to plug in a value into x that when you subtract, okay, will give you a value greater than 0.5. And actually, I think that should have been written as like absolute value. But either way, so what they're saying here, and we can kind of just go through our chart. We'll make up a quick one, because since we have that information, we can quickly draw a normal curve and kind of gather information from there. So let's say that's our normal curve. Okay, so this being our mean here, I know it's not perfect, but we have 18.5. So we know if we go plus a standard deviation, so plus 1, we're going to be at what value?
19.
That's right, we'll be at 19 because we've added 0.5. And if we go to minus 1, we'll be at
18.
We'll be at 18 because we subtract 0.5. So that's plus 1 deviation and minus 1 deviation. 2 deviations, let's go put it there, are going to give us, do those in blue, 19.5 because we add another 5, and 17.5 because we took away another 5. So this is 2 deviations and 2 deviations. And finally, 3 deviations like this. That's going to be 17 and 20, right? And that's plus 3 deviations and minus 3 deviations. Okay.
3.
Oh, sorry. 3. So what they want us to find here, I'm going to use a highlighter, is a proportion that is more than 1 deviation away. So in other words, we're looking for something in line with that value and covering all this space, because this is where 1 deviation is. So this is more than a deviation away from our middle. And we also want from this side going the other way, because that's also, even though it's not in the same region, it's still more than 1 deviation away. Now there's a very simple way to do this, okay? We can find out this value because we already know from some of the information they've given us, we already know how much this percentage is. How much is within 1 deviation? Do you remember the percentage?
68.
That's right, 68. So if we're just looking outside of that, we can really just quickly go 100, subtract our 68 to figure it out, and that's going to be, let's see, 72. No, not 70, 32. So in other words, this should be 32, right? But again, because it's split, half of the information's here and half of it's here, we can even break it to be more specific. We can find out how much is less or greater than negative 1 deviation, and we find out how much is greater than 1 positive deviation. Since the total is 32, so all of this yellow equals 32, we would split that in half because they're symmetrical. It's an identical amount. So let's go 32 divided by 2, and that's going to give us 16%. So we know 16% of the data falls to the left of 1 standard deviation, and 16% of the data falls to the right. So we're going to use some exact values because it's not exactly 68. There's a bit of a decimal in there. But this is a good idea of what we should be getting as an answer. Okay, so now what your professor has gone about doing when he's explaining his note here, portion of sparrows that humerus bone, blah, blah, blah. What he's done, he's written the proportion, and he's rewritten like this. X is less than and equal to 18 millimeters, or X is greater than and equal to 19 millimeters. And that makes perfect sense because 18 millimeters is exactly where our 1 standard deviation to the left is, and 19 millimeters is 1 standard deviation to the right. So what he just wrote there in mathematical terms, and this should be millimeter. In mathematical terms, what he's written is x is greater than, so larger than 19. That makes sense. This is larger than 19. And 18 less than and equal to, so at 18 and less. Okay? So we've kind of deduced what he's trying to write there. And what he did is he split these. He split these amount because they are symmetrical. Okay? So what he did, instead of just writing or, he put probability that x is a less than and equal to 18 millimeters. So that's the proportion there, plus the proportion that of x that is greater than and equal to 19 millimeters. So he split it into 2 parts, which we kind of did there to find that 16 and 16. He split it into 1 part here and 1 part here, and that's what he's done with the question. This is the left hand, so less than, and this is the right hand. Does this make sense so far? Mm-hmm. Kind of. He split the question up so that he's talking about the 2 different parts. And then, because it's symmetrical, we actually really don't need to find each individual part. We can really just find the density of one, or the average of one, or not the area. That's what I was looking for. The area underneath the curve of one of them, and multiply by 2, because these are identical. They're both 1 standard deviation away from the mean. So this area here and this area here are identical to each other. So instead of writing it that way, what he decided to do was, because z-scores, remember, z-scores are always to the left, right? So this one, because it's to the right, is a little harder to calculate because we have to do this, and then we have to take 1, subtract that amount. It's easier just to look at a z-score, and since these are both identical values, just write it as one question. He chose the x is less than and equal to 18 because you can look directly at that amount and find out 1, and then he multiplied it by 2. And the reason he multiplied it by 2 is because this amount and this amount are identical. So there's really no reason to go about finding the more difficult one. We just solve the easier one and multiply it by 2, and that will give us the total amount of the curve. Okay, so that's what he's written there. So what he did is he went into the z-score and he actually discovered what the amount was. So let's go into our z-score chart because it was 1 deviation, right? So we here have a z-score chart, and we're talking about -1. So I'm going to scroll down a little. Here we go. -1 is at 15. This is the amount for -1 away. So the area to the left of it is 0.1587. Okay, so when he looked up that z-score, okay, he discovered that this amount, so 2 times, and then this bracket here, we'll do that part in green. This will be our green. This bracket here is actually 0.15, what did we say, 78 or 87?
87.
87, okay? That's the area to the left, right? And we said it was roughly 16. This is pretty close to 16 as a percentage. Technically, that percentage is 15.87%, right? We did a little bit of rounding just so we have general knowledge about it. So it's almost exactly 16. Well, since the one to the left is 15.87, all we have to do is, because we know it's symmetrical, we multiply that value by 2. Okay, so that probability can drop off, and we just have 2 times 0.1587. Okay, and when he puts that into a calculator, we'll bring up our calculator here. 0.1587 times 2, 31.74, right? So in other words, the area under that curve is 31.74, which is approximately, or actually, sorry, exactly 31.74%. And what did we say the percentage was going to be?
32.
32. We are pretty much on, right? If you were to round this, it would be roughly 32% of the data is outside. Now, this is a more exact number, and he may be looking for a more exact number, so you'd have to go about doing this.
So, but if he wasn't, I could probably just do...
Yeah, you could say it's roughly 32%. Like, you're almost exact with that average, and those are just some known things we have. Now that we've done that, I can technically show you how to calculate that without the times 2. And that's the harder way to calculate things, and I can show you that. The way we would calculate it is A, finding this part, okay, which we've already done. Okay, so I'm going to do that in part in purple. We already know the area under that curve was 0.1587, right?
Mm-hmm.
Then what we could find is the other standard deviation. Now remember, the other standard deviation, when we solve for one standard deviation in positive, it's going to give us this area, not the yellow. Okay,
Right.
so we'll have to subtract to do that. So that's fine. Let's look for positive 1 in our z-scores. So we'll go to our z-scores, scroll down, and positive 1 is...
Oh, no, it is there.
Oh, I think it's right here.
But that's...
Oh, sorry, yeah. 0.8413. Is that right, what you got?
Yes.
Yeah, 8413. Okay, so let's write that down.
Oh, wait. Positive?
Positive 1, yeah.
Oh, yeah.
0.8, read it to me.
8413.
13. Now, this amount and this amount aren't the same, right? But the reason being is because this amount, which is our 15, is to the left of that, where our 84, that's the area to the left of this. But we're not looking for the area to the left of that. We're looking for the area to the right of that. So in order to actually find the area to the right of that, we have to take 1 and subtract that amount, right? 8413. Okay. So when we take 1 and subtract that amount, we'll bring up our calculator. 1 subtract 0.8413 is equal to 15.87. Perfect.
Oh.
0.1587. And now, like we talked about, we have two identical areas. So normally we would just add those now. But adding those two things is the same as multiplying by 2. If I go 0.1587 plus 0.1587, I'm going to get 0.3174, which is exactly what our answer was when we multiplied by 2. Okay, so what I just did the second time was the long way of doing it. Okay, and that's what kind of you're doing in those other questions. We had to find the area to the right and to the left. But because we knew it was symmetrical to start with, the fastest way to do it was just solve the one to the left and multiply by 2. And that would give us the total area that we were looking for under the curve.